This video is made for 10th standard. The topic name is Quadratic Equations. Definition. The equation ax square plus bx plus c equal to 0 and a not equal to 0 is known as quadratic equation. Ax square bx plus c equal to 0 and a not equal to 0. That is most important. Suppose we want to call this equation is what a quadratic, definitely that a not equal to 0. Suppose a equal to 0 now, the first term will not get. So what we will get remaining now? Bx plus c. So that is called what? Linear equation. So want to say quadratic, that a not equal to 0. So then only is called what? Quadratic equation. A not equal to 0. It's very important. Next. Observations. A, B, C. These are what terms in equation ax square plus bx plus c equal to 0. So we have some names for these letters A, B, C. First, A always called what? Coefficient of x square. B, coefficient of x. C, constant term. So it is a quadratic equation, and A, B, C are called coefficients of x square, x and constant term respectively. Okay. So this is a graphical interpretation for what a quadratic equation. If you draw the graph of a quadratic equation ax square plus bx plus c by taking y is equal to, we'll get what a graph like this. I mean y is equal to x square plus bx plus c suppose taken, and if you draw the graph you will get like this parabola. It's called what? A parabola or u-shaped curve. Okay, parabola. Fine. Next, objective. The purpose of this chapter is to study the nature of solution of the quadratic equation and to find them. So that is the purpose of this chapter. Next, let us consider the quadratic equation ax plus bx plus c equal to 0. In the whole discussion, that is our standard form, x square plus bx plus c. So I want to discuss with you about what roots, what is meant by roots. So let us define what roots of the quadratic equation. If x is equal to alpha, that letter is called what? Alpha, is said to be a root of the quadratic equation ax square plus bx plus c equal to 0. So want to say that x is equal to alpha is a root of this quadratic. So you have to calculate that equation by substituting x is equal to alpha itself. So ax square plus bx plus c, no? So in the place of x you have to replace alpha, and again you have to calculate the entire value, the total value. The total value become what? 0 by alpha. By alpha we can say that alpha is the root of the quadratic equation. So there is a equation ax square plus bx plus c, and you have to replace something that x is equal to alpha into that equation. It will give what? One value. If that value is equal to 0, then x is equal to alpha is called a root. If it is not equal to 0, by substitution of x is equal to alpha, that x is equal to alpha is not a root of the equation. So only in the case of equal to 0, that x is equal to alpha is called a root of the equation. Fine. Next, number of roots of the quadratic equation. So how many roots we can expect? Like, but how many alphas? Alpha 1, alpha 2, how many numbers we can check whether that the whole equation become what? Equal to 0 for that alpha or not, that we want to know, no? So this is the discussion is taken under this heading, number of roots of the quadratic equation. So suppose I'll take what the product x minus alpha into x minus beta. I have some reasons behind that. So first we multiply, let's see what we'll get. So first distribution x into x minus beta minus alpha into x minus beta equal to 0. Multiply x into x square, x into beta is what? X beta, alpha into x is alpha x, minus to minus beta, alpha beta equal to 0. So rearrange it again. So take what? Minus x common. So x square minus alpha plus beta x plus alpha beta equal to 0. So now it is like what? A quadratic equation. It is like what? Quadratic equation. So if you multiply these two, we'll get what? Quadratic equation. So the discussion is, so the product x minus alpha into x minus beta equal to 0 now, either x minus alpha equal to 0 or x minus beta equal to 0. So this shows that either x is equal to alpha or x is equal to beta. So we'll go what? Reverse. If x is equal to alpha or x is equal to beta, we'll get what either this factor equal to 0 or this factor is equal to 0. So these two, the product of these two factors produces what? One quadratic equations. So therefore every quadratic equation has at most two roots. I mean either x is equal to alpha, x is equal to beta are called what here? Roots. So for every quadratic equation we can generalize that there we can expect what? At most two roots. So how many roots are there for a quadratic equation? At most two roots. Okay, so at most 2 means either 0, 1 or 2. 0, 1 or 2. That is the meaning. Nature of roots. Nature of roots. See this quadratic equation ax square plus bx plus c equal to 0 depends on delta is equal to b square minus 4ac. The roots of the quadratic. Suppose I said what there we can find what are two roots, x is equal to alpha and x is equal to beta for every quadratic equations. Okay, suppose if you get what are two values alpha and beta, now you have to stop what to find the roots of the quadratic equation because it will have what at most maximum two roots only. So no need to try for what any other numbers. So before that we can go what some study the nature of roots. So what are the numbers we can try for what roots of the equations. That's what the discussion taken under what a nature of roots. The roots of the quadratic equation ax square plus bx plus c equal to 0 depends on what the value delta equal to b square minus 4ac. So sometimes it is called what a discriminant of the quadratic equation. So delta is equal to b square minus 4ac. Okay, so here it depends on what three signs. Okay, so I took it as what as some symbols: red, green, yellow. Okay, symbolic representation. So the delta b square minus 4a is less than 0, one case. I mean this value you have to calculate by using what are coefficients of x square, x and constant term. So we'll get what three different sign. One is what that net b square minus 4ac less than 0, or b square minus 4ac equal to 0, or b square minus 4ac greater than 0. So three values, three possible signs we'll get: less than 0 red, equal to 0 green, greater than 0 yellow. So red, green, yellow, less than 0, equal to 0, greater than 0. This is what a symbolic representation I want to take with this picture. So if less than 0, we can say no real root exists for the quadratic equation. By real number you will not get what any roots. So you should not try by what real numbers. So immediately you have to stop by stating that no real root exists for the quadratic equation if the discriminant b square minus 4ac less than 0. I mean red, if it comes you have to stop to find roots. Okay, if it is equal to 0, I mean red, green, if it comes what a green equal to 0, then you can state that there is what only one real root, exists. So real root exists, but they are what equal, because I stated already it will have what two roots. But if it is equal to 0, you will not get what two different roots. You will get what only one, that is what called the equal roots. So green comes only one, red comes no. Next yellow greater than 0. If this b square minus 4 is greater than 0, then you will get what the real roots, but two different real roots. We will get what two different real roots. So less than 0, no real roots, equal to 0, real root, but only one you will get. Greater than 0, real roots, but both are what different. So two different real roots you will get. So red, green, yellow. Red means no, green means 1, yellow means 2, less than, equal, greater than. Okay, no roots, 0 number of roots, 1 number of roots, and number of real roots is what 2, 3 cases. No means 0, equal means 1, different means 2 real roots. Okay, so the same study we are going to use what such a diagram, mind diagram. So delta, the same delta you have to calculate. If it comes less than 0, you can state that there is no real roots. So delta you have to calculate. If it is less than 0, immediately you can conclude no real roots. Okay, so in this case, your parabola will come like this. So that parabola will not touch what x-axis. Okay, wow. So no real roots means the parabola is what just away from the real line. That is graphical representation. Suppose less than 0. No, you are saying what no. I mean, I asked to find what delta value you calculated, and suppose you are seeing what it is less than 0, immediately you have to conclude what no real roots. But you are saying what no, you are getting what something else. Something else means it is what greater than or equal to 0. The delta is greater than or equal to 0. So delta equal to greater than or equal to 0. So now you have what two choices, either delta greater than 0 or equal to 0. Now I am asking whether your delta is equal to 0 or not. You are saying yes. If you are saying yes, so you can conclude you have what equal roots for the quadratic equation. In that case, the graph, I mean the parabola equation of the graph of the parabola just touch the x-axis. Here does not touch. Here it touches what x-axis. Okay, that is what equal roots. The diagram for equal roots. Suppose again the delta equal to 0 is not 0. Not 0 means I told you there are two cases only from here. So greater than 0 or equal to 0. If it is equal to 0, you have to go what equal roots. No, you are saying no. It is not equal to 0. Equal to not equal to 0. No? It must be what greater than 0. In that case, you will get what distinct real roots. The graph of that equation will be like what crossing x-axis at 2 points. So two distinct real roots. The parabola will cross the x-axis at 2 points. Equal roots, the parabola just touches what x-axis. No real root means the parabola will not touch what any x-axis. Okay, cases less than 0, no roots, equal to 0, equal roots, less than greater than 0, distinct roots. Okay, that is most important. Okay, fine. We'll go what examples to find what the nature of roots. So I'll take what three equations. 1, 2x square plus 3x plus 4 equal to 0. 1, 4x square minus 12x plus 9 equal to 0. X square minus 6x plus 5 equal to 0. So I'll check one by one. Just we are going to study the nature of roots. So compare the equation 2x square plus 3x plus 4 equal to 0 with the standard equation or general equation x square plus bx plus c. So we can say a equal to 2, b equal to 3 and c equal to 4. So I'm going to find the discriminant delta equal to b square minus 4ac, because this will turn into what three different, this can be what greater than 0, less than 0 or equal to 0. So each case will give what specific results. So I have to find what this delta b square minus 4ac. So I substituted b value. What is b value? 3. So 3 square minus 4, a value 2, c value 4. Okay. So b square minus 4ac substituted. I calculated 3 square 9, 4 4s are 16, 16 2s are what 32. So it is what minus 23. So minus 23 minus delta less than 0. So less than 0 means red. Red means no real roots. So no real roots exist for this quadratic equation. That is the conclusion. Okay, this quadratic equation will not have what any real roots. So compare. So second case, compare the quadratic equation 4x square minus 12x plus 9 equal to 0 with a standard or general equation ax square plus bx plus c. So a equal to 4, b equal to minus 12, c is equal to 9. Again I will calculate what the discriminant b square minus 4ac. See what is b square? B is what minus 12, so whole square, that is what b square minus 4ac. A is 4, c equal to 9 substituted. So 12 square 144. So 16, 4 4 is 16, 16 into 9. 16 into 9 is what? 144, right? 16 into, yes, 144. 144 minus 144 is 0. 0 means green. Green means as equal roots. It has what? Equal real roots. Equal real roots. So we'll go over next case. Compare the third equation with the general equation x square. So you can find a is equal to 1, b equal to minus 6 and c equal to 5. Again we'll find what? The discriminant. B square minus 4ac. What is b? Minus 6 the whole square minus 4ac 1 5. So substitute and multiply. So minus 6 whole square is what? 36. Minus 4 5 are 20. So 36 minus 20 is what? 16. 16 is what? Greater than 0. Greater than 0 means LO. So it has what? Two distinct real roots. Two distinct real roots. Okay, less than 0, no real roots. Equal to 0, green, equal roots. Greater than 0, yellow, two distinct real roots. Okay, in the next video, we'll see how to find roots of the quadratic equations. Thank you. The best.